Greetings and welcome back to a really exciting day of organic chemistry. Today we'll be looking at keto-enol tautomerization. These are three fun words in which you probably know part of one of them. So, keto. Keto is short for ketone. Now ketone just looks like this. It's a C double bond O with carbons on both sides. And enol is two different things. It's an alkene and an alcohol jammed together. So it's something that could look like this. It's got an alkene and an alcohol, specifically where the alcohol is attached to one of the carbons in the alkene. So that's what an enol is. And tautomerization is something that we will jump into right now. So let's look at some mechanisms really quickly. In a basic solution, if you start off with a ketone, well, we know some reactivities here. The reactivity of a carbonyl is that it is electrophilic, and therefore the CH next door on either side could be acidic. So if you add in some base, for instance OH-, this guy can take off the hydrogen from that alpha carbon, or the position directly next to the electrophile, which would give us a carbanion, which is stabilized through resonance and can give us a C double bond C and an O-. Well, if this whole thing is in water as well, which base has to be in, then that O- can take a hydrogen off of water and become an enol. Ooh, resized. Let's bring that back to where it was. All right, so we have here our keto and here our enol. Well, we can also go backwards. So let's do the exact same thing in reverse. What happens if I start with my enol and I add in some hydroxide? Can grab that hydrogen off of the enol, which would then give me that O-. Well, resonance goes in both directions, so I could then end up with that C-. And what if instead of that C- undergoing resonance, it grabbed a hydrogen off of some water? Well, then it would turn into our keto. So therefore, keto-enol tautomerization tells us that using basic solution, a ketone can turn into an enol, and an enol can turn into a ketone. So, under basic conditions, ketones and enols go right back and forth. They exist in equilibrium. Well, we can do the same thing under acidic conditions. So let's start off with the exact same thing. We'll do this under acidic conditions. So we could start off with this guy. And I'm going to add in a little bit of acid in water. Well, this guy can grab a hydrogen, which would give me a protonated ketone, which has a plus charge up there. Well, in a ketone, normally this oxygen is pulling electrons away from that carbon, but in the case of this ketone, this oxygen is pulling electrons away from this carbon even more so. So therefore, this guy is not just an electrophile, but it is a screamingly strong electrophile. And therefore, the neighbors are screamingly strong acids. So let's put that hydrogen back on there. And it turns out that when you have that strong of an acid, any old base will do to pull that hydrogen off. So we could have a base pull that hydrogen off. And these electrons would come over and form an alkene, kick the electrons up to the carbon, and we would get new double bond, and that double bond OH would become a single bond OH. And we would turn directly into an enol from our ketone. All right, So, what if this guy wants to go in reverse? Well, we could certainly do that. What happens if we add in an H plus and we go in backwards? Well, these electrons can come down here. That guy can grab an H, in which case we would turn back into this guy. And certainly at this point, we could add in our water, which could just deprotonate that positively charged O, and would turn this back into a ketone. So it turns out that in acid, we also have a keto-enol reaction or equilibrium, in which on its own, in solution, the ketone goes back and forth to the enol. So let's minimize this part as well. So what we see in both cases is that the same thing is happening. Ketones and enols turn into each other on their own in any type of solution that is a little bit acidic or a little bit basic. And therefore, anytime you get an enol, it can turn into a ketone. And anytime you get a ketone, it can turn into an enol. And in general, this happens all by itself, because their solution is usually going to be either a little bit or a lot acidic or a little bit or a lot basic. And therefore, we pretty much can't prevent this from happening. So the only thing to consider is which one is more stable. Well, what we have found experimentally is that the one is more stable is this guy right here. So in general, anytime you make a ketone or an aldehyde, it tends to turn into, on its own, an enol. But anytime you make an enol, it tends to turn on its own into a ketone or an aldehyde. And this happens without really any assistance except for being in solution. But because the ketone or the aldehyde is lower concentration, in general, if you make an enol, it's going to turn into a ketone. And in general, if you make a ketone, a little bit turns into an enol. Thank you very much. Let's try a question. And if you have any questions, please bring them to class. Enols!